I think I would love to use like the next, like, let's say 10 minutes for or so. We had a couple of talks, and I think there's definitely some of the, like, let's say like the Julia standards of how do you write like big models. And I think there's a lot we agree on, things like using, for example, multiple dispatch in order to make things to really make use of like extendability. That is, I think, basically everything that absolutely makes, where everyone agrees that absolutely makes sense. There's a few of like the smaller things, like you could do like in Julia, you can do like this way or that way, and you probably end up with like similar results or so. But in the end, I believe, I mean, already that everything is open source, we kind of share our efforts of like how we do things, and we kind of just look into each other's like source code and like, this is how it's done in that model, and this is how it's done in that model. But I was wondering whether like people here have more opinions about like how we can kind of lower this hurdle for someone who comes into any kind of Earth system modeling with Julia, to lower this hurdle of like, this is a good practice of how to do things, and whether people have some kind of opinion on that, whether we can come up with some kind of like, I don't know, guidebook in whichever form that takes, to kind of make sure that we really have a space where we can also exchange these ideas of like, how do we build Earth system models in Julia. Everyone gets 10, 20 seconds to digest that. Opinions? No? You have. Of course you have.
Well, maybe I just want to ask you a question. I think conventions and standards are a really good idea, but how do you? I mean, it's going to emerge organically, right? Like, it's not going to be.
No, I absolutely agree on that. So there's definitely some kind of like how these things evolve dynamically. This is always going to happen anyway, right? And like one project is a bit more advanced than another, and so you basically look at the more advanced. This is how they did it. But I was wondering whether there's also a form that we can somehow like document these like. I mean, like in the mini symposium title, we called it like anatomy, right? Like where we can kind of like document a little bit better like the anatomy of our models, so that people can more easily understand how they're built up, and how could they be like, where the parts where you can exchange the heart and put another heart in, whereas like the skeleton, if someone wants to build a similar model, how can you like make sure that you have like a similar skeleton for another model, so that you can just like take on the heart and put it into another one. And I was just, basically just wondering whether, because in the end, I don't know, Speedy Weather today, for example, took some inspiration by like me talking to Greg, but also by like me looking into the source code of Oceananigans. But I was wondering whether there's like, somehow like another way of like fostering a community on that, to kind of exchange all these efforts.
First, I want to say that my perspective is one of a student. And I think that, climate modeling is something that's like inherently creative. So it's hard to just have like rigorous guidelines for things that, people kind of want to be creative with and take in their own directions. But something that I think a lot about when, like, for example, in your model and in Oceananigans, how you create like a model object and then you have the simulation object with a time stepper. I'm sure there's a reason for that, and you guys probably both like encountered like a set of mistakes that led you to make that decision. So maybe some sort of form of like common pitfalls or frequently asked questions, or just mistakes that were made by previous people, so that I don't make those mistakes when I'm trying to create my climate models, would be really helpful.
Yeah, I think on that, I also took inspiration from Oceananigans source code and created like the simulation model nested structure. And thinking, about coupling now, and as you guys are also thinking about coupling now, I could see something like Klima Earth, or this sort of really easily extendable coupling framework sort of starting to set the tone for something in that form. Just that way we can hook. It would be really, really cool to have a framework that exists just to be able to hook basically any set of models developed in Julia together.
I don't really have an answer, but I have like similar questions because I'm also like working on like large scale models, more like just for like smaller problems in the atmosphere. Yeah, and I think there are quite a few commonalities in like the difficulties we've encountered and like the solutions we came up with. And yeah, one aspect that hasn't been brought up at all, but where I think there's also quite a bit of room to like discuss approaches that have worked and not worked is in terms of testing and validation, where like, yeah, like how do you like do modular tests for like verifying the accuracy of your models, or like parts of your models, more global integration tests. Yeah, I don't know, like I'm sure like other projects have also come up with like their ideas of how to do that, and that might also be something to discuss.
Yeah, I mean, absolutely. I find that a very difficult topic in general because you have such a complex model, it's expensive to run. What do you actually, like, if you just think about unit testing, which of the units do you actually test, right? Like some of the things only fail if you put them all together, right? So it makes it absolutely really hard. Yes, I agree with that. Yeah. Are there any other like users of, let's say, models like Oceananigans here that feel like there's like a certain hurdle towards, I mean, it obviously tries to have the barrier as low as possible, but is there still like any kind of hurdle of like using it and understanding how you can make it more, how you can extend these kind of models still?
Actually, I may follow up on an earlier question. It sounds like currently these model developments are focused on academic and research uses, which makes sense, but a natural question arises, is there an end state where you'd want these models to be used in operational forecasting, both for short-term weather, medium forecasting, and long-term climate? And how would you approach that? Or how would you get from here to there?
Yeah, I mean, I agree. That's absolutely like a big question, right? So if you think about an interface like Oceananigans or Speedy Weather have, how do you, like an operational center, how would they set on top of that? I mean, I think in the end, it's exactly the same. It's very technically straightforward, but there might be a big hurdle in terms of, yeah, the existing structures in these operational centers are not, they don't think like an undergrad student thinks, right? Which we try to build the models for. And so I guess, yeah, I don't know whether there's a big hurdle for that. No, any other?
I was just gonna say, in terms of communication, if we want to not only have like this discussion, but maybe like kind of open a route of communication for this group, maybe we could have like a new channel on the Julia Slack or something like that for like climate model developers and users to kind of just like have some of this conversation and keep track of like pitfalls like we were mentioning, things like that.
Okay, so when we, Chris and Milan and I originally had this discussion, I think one of the things I proposed was some sort of, along those lines of a semi-regular Zoom call maybe, I don't know. We do, so I'm on the Julia HPC's chat, and once a month we have just like a Zoom call, which is, there's technically an agenda, but it sort of ends up being, you know, whatever, some people showing off what they've been working on, some people trying to, you know, talking about a problem they had, and sort of a group discussion of trying to fix things. And so that was this was sort of one idea, was maybe to have some sort of semi-regular coordinated meeting where we discussed some of these, you know, common issues. But on the, to sort of answer Milan's original question, I think sort of there's a few things we can look for commonalities. One is sort of the very low level pieces. So, I mean, Skylar mentioned the sort of geometry object, common geometry. I've noticed the word mesh used a lot. I actually, when doing Climate Core, I decided to avoid the word mesh because it was unclear what that meant. So we specifically went with grid, which is maybe not a better choice, but sorry, we went with mesh, not instead of grid, sorry, the other way around. So grid, but yeah, but just, but I ended up noticing that a lot of people tend, especially when trying to do things, you're trying to often use very similar constructs to, yeah, do similar things, particularly people who want to do things interactively. So you end up like, what is some sort of thing? You have something living on a domain. Some sort of, it's an array, but also has all this extra stuff in there. So, and we all sort of notice a lot of commonalities there. And then the other thing is just output. So how do we sort of convert between different things, different spaces, convert things to NetCDF or whatever people are formats, or reading it, And so there's some other commonalities there, I think, that it could provide a good venue for, for those sort of things.
Do you think, is there scope for like more literature, like literature about software design? I don't know, like you could write a paper, like this is how we think that you should, these are the main pieces of software for physical simulation in a high level language, for example. I'm actually curious if anything like that has been done in the past, like, for the prior generation of languages that weren't high level as well.
I don't know the answer to the last question, but okay, great.
I don't recall the author, but there's someone that posted on the web how to use Julia in scientific usage, and all the details about how do you manage code, how do you keep your versions, how do you have a continuous integration, and so those from the scientific community, we don't always have all those courses, those background courses the computing education has. So I was going to look into it and recommend it to my colleagues. So maybe you want to look into that. Just scientific computing Julia, and I think you would get that YouTube.
Amazing, great. Yeah, I mean, Greg, to answer your question, I feel actually we're kind of at a state where I believe we kind of still have to prove that actually if you follow the kind of, let's say, like the shenanigans logic, implementing that into other components, that you actually, once you put them all together, that you actually end up with a very usable climate model, which we don't have yet, like a climate model that has at least ocean, atmosphere, ice, and a bunch of other components, let's say, like, I don't know, land and so on in it. But at least at that stage, I would absolutely recommend to just like write this down and kind of write a, let's say, like almost like a high level, by the way, this is our philosophy behind it. When we talked a little bit about this philosophy of like, does the coupler dictate the Earth and atmosphere what to do, or the other way around, including sea ice? And I feel like these philosophies could absolutely go in there, because I believe they have not necessarily always been documented. They may have, but they may have also been approached very differently. And so even if it's like, let's say, like a high level documentation paper for us that is kind of like obvious, it may actually trigger a nice communication, or might be a nice document to share with other people that are kind of like stuck in their Fortran world, to say like, hey, this is actually what we can achieve by simply like changing some of these paradigms that people usually get stuck in. Yeah. Any other ideas on that? On this issue, because otherwise I would absolutely suggest I can just take the initiative to like create I think I may have did I do this already? I think like creating like a Julia on the Julia Slack channel. I think I did that already. As a climate channel, yeah. Maybe you would just hijack the climate channel or something. I know this is the problem, right? Yeah, but maybe we can use that for like smaller discussions or so, and then definitely have something like a monthly meeting or so. That might be good, and then just like whoever is keen to join just joins, and we can kind of like talk about specific issues of like, so people can even come with their own problem and say like, hey, this is the problem I'm currently facing. My code ends up being very, very non-linear, and I don't know which parts are executed in which order. Typical problem that I sometimes have. Yes, Gael.
Following up on the Slack thing, but also Zoom calls. So Zoom calls, like a periodic Zoom calls, I've said so to a few people here before. I would join them if Clima was kind of invading that way. as far as Slack, please use GitHub instead. Like GitHub is way more full-featured. It's good software. Slack is not. Slack is evanescent communication in the case of Julia because we don't want to pay the fees that come with having a long thread. Yeah, there's a million of them too. That's the other issue is everybody has their preferred version of Slack, right? And Zulip might be better, indeed. I'm on like 5 or 6 of those things already. There's something called Matrix, which is kind of nice because it's blockchain. But GitHub is a very, very good framework, and it allows for a lot of discussion space. It does provide, privacy if you want it, etc. So, in my opinion. There's just one, but GitHub would be a much better venue for this than Slack.
And people can also read it without an account. Maybe.
Do what?
People can also read it without an account. You
That's
don't have to
also
be invited
true,
into
yeah.
the group in order to read it, right? But like you could, use one of the existing GitHub organizations, or like create a new one, and then basically make everyone who wants to be a contributor. And then you can everyone can create their issues or like upload like file snippets, for example, link them into the issues and so on. Yeah. I think that's definitely another way to do that. Cool, amazing. Are there any other final comments? Yes.
Yeah, so it seems to me we're still in the stage of community building when it comes to Earth System, Dynamics, and Julia. And so I'm taking a step back, not talking about Oceananigans or Klima or anything, about some of the barriers to entry. And in all of the discussions here today, we've heard multiple dispatch being put forward as one of the great things about Julia. I think that's because probably everybody in the room's used Julia for more than 2 to 6 months or something, and that's when you realize multiple dispatch is great. But for geoscientists that aren't as computer science savvy, Julia is a more powerful tool than we're used to, and powerful tools are great, but you can hurt yourself with a powerful tool. And multiple dispatch, I think, falls in that category, where composability, maybe just the error messages that you get from method errors, I think they actually stop a lot of people from uptake on Julia. That's what I've found the biggest barrier in the beginning when I was learning it, when I was beginning to work with students with this language. So I think it's something worth addressing.
Method not found, is it?
Method not found. Wow, that kills me.
I mean, the Julia logic is definitely just define it, right? If it's not defined, then just define it yourself. Yeah. No, I absolutely agree. I mean, for me, Julia was also the language that suddenly kind of like pulled me into the computer science world, and where I was like, oh, suddenly I start understanding like some of these concepts that previously were just like weird blurry black boxes for me. Like, what does the compile actually do? What happens on the parsing step before that? This kind of stuff, right? Multiple dispatch and so on. I mean, not that I ever learned that actually in my undergrad or so. I absolutely agree. There's definitely also, it's easy for us that already have made the step to come to a computer science conference to think about concepts that in a way that they're like easy to understand, whereas actually many of our users don't necessarily want to deal with what is multiple dispatch. Yeah, no, I agree. I think we can absolutely close the session here. I was very happy for all of you to come, for all the speakers. We can definitely thank the speakers in a second also. But before we do this, I think we talked a little bit about having dinner tonight. So if anyone wants to join, we kind of thought about something like 7:30, which should be like after the poster presentations, and then maybe going over to the Cambridge Brewing Company, CBC, which is, I don't even know where we currently are. Somewhere over there, it's like a 5-minute walk or something, and then basically, meet there at like 7:30, and probably, I guess, like some of us beforehand will 5-10 minutes before, we'll probably start from here, walking over, look for familiar faces. Otherwise, we see each other at 7:30 there. And thanks for everyone to come. Thanks for all the speakers. And thank you.